So there's two ways to approach this particular problem. I wrote the gross way out ahead of time because I don't want to write all this because my handwriting can be sloppy if I write and talk at the same time. But this first way is me just straight up not really thinking too much about trig and just applying some calculus. So I'm going to use the rules like the derivative of the cosine is a negative sign and those other formulas from that note sheet. I'm going to use the product rule, and I'll talk you through what's happening here. But then I'm going to also encourage you to sometimes think ahead a little bit and think about some of the trig and other math you learned and see if that is helpful. Because usually if you're having to do this much work to solve a problem, there's an easier way. So what's going to happen is I'm going to look at this problem and see that I've got these two trig functions being multiplied together and this one being subtracted. So I will use a product rule for this part and then just take this guy's derivative. So applying the product rule to cosine times cotangent, I've got the first times the derivative of the second plus the second times the derivative of the first. So all this stuff is a result of me applying the product rule with the formulas for cosine and cotangent derivatives. And then this guy's derivative is negative cosecant cotangent, but there's already a negative there, so we get this second part of the expression plus cosecant x cotangent x. This is a pretty ugly looking expression. I don't like all these negative signs, but we can deal with them. If you multiply these two guys together, you get negative cosine x cosecant squared x. Multiplying these together gives negative cotangent x times sine of x, and then this of course stays the same. And you could really stop here, but if it was multiple choice, there'd be more work to do. So here's how the rest of the work might look. I think on the next line, what did I do? Oh, I left this alone because there was nothing to do. I thought of cotangent as the cosine of x over the sine of x, and those sine of x's canceled. So this was like cotangentially cosine of x over the sine of x, and these would have canceled. So that's where this negative cosine of x is coming from. And then this, there was nothing really to do. But then I was like, okay, this is still pretty gross, so let me start looking at things in terms of sines and cosines and seeing if things clean up a little bit more. Cosecant squared is 1 over sine squared of x. That doesn't seem too helpful. There's nothing to do with this. Cosecant is 1 over sine. Cotangent is cosine over sine. Oh, so now I see something. I see that this is going to equal cosine over sine squared x. And this is going to equal negative cosine of x over sine squared x. And this guy is just staying alone. But the point is, this guy and this guy are opposites. One's negative, one's positive. So they'll cancel. And my final answer would be simply negative cosine of x. So that is certainly a way to do that problem. But another thing to think about is from the very beginning, when you just have y equals cosine of x, whoa, see what I mean? Y equals cosine of x, cotangent of x, minus cosecant of x. I'm just going to take a quick moment to think about what happens if I rewrite this stuff in terms of sines and cosines before I even apply any crazy derivative rules. Cosine, I can't do much with that. I'm going to leave that alone. Cotangent is cosine of x over the sine of x. And then cosecant of x is negative 1 over, it's not negative, negative was just there. Cosecant of x is 1 over the sine of x. And I'm kind of encouraged by the fact that these both have a denominator of sine of x. This can be rewritten as the cosine squared. So this expression I can think of as cosine squared x over sine of x minus 1 over sine of x. Just to clarify, keep in mind, right now all I'm doing is rewriting this function. I'm not doing any calculus yet. This is just trig. Because these guys have the same denominator, I can go ahead and combine the numerators to get a cosine squared x minus 1 over sine of x. And now this numerator reminds me of that fun fact that you all want to know and look out for. And the fact I'm talking about is the fact that cosine squared of x plus sine squared of x equals 1. That's not what this is, but this is if I take, you can see how if I take this and subtract 1 from both sides and subtract sine squared from both sides, I'd get cosine squared x minus 1 equals negative sine squared x. So this can be replaced with a negative sine squared of x over sine of x, which one sine will cancel, so negative sine of x. So what does that tell me? that tells me that this gross expression is really equal to this. Just y equals negative sine of x. And so the derivative of sine is cosine, and that negative was there. So we can get the same answer with, you have to admit that it was less work. It was less work. You didn't have to worry about the quotient rule and all this like multiplying and factoring and all kinds of stuff. It's still work. It's just less work. So if you find yourself having to work with a bunch of crazy trig stuff and fractions going this way and that way, just stop, think, go back to the original problem and see what happens if you think about it in terms of sines and cosines off the bat, and sometimes it becomes easier. All right, guys, good luck. You can do this. It's going to be fun.